In this lecture, we will talk about application in physics. Okay. Look, again, this is a central angle, theta. This is the radius, OA, radius. And then central angle, AOP. And the length of AP is S. You may assume there is an object travels along this circle from A to P. You see, this is not linear. This goes along the circle. So how fast is the speed? We know the speed is travel distance from A to P. That's the length of the arc. That's S. Divided by time. The distance divided by time, we got speed. Okay? So here basically the linear speed from A to P is the travel distance S, the length of the arc, divided by time. And this speed is called the linear speed. So normally we travel in a highway, the speed we were talking about is linear speed. Okay. Now we know the length of the arc equals RS, radius times the corresponding angle, central angle, theta. Replace S with theta because those two are equal. Replace that. Now R is a constant. Okay, you pull it out. And then that's basically theta divided by T. So what's the meaning for that? Theta divided by T is the amount of time, and then it takes this amount of time T for the central angle extended from OA to OP. Okay, so it takes the amount of time T for the angle goes to this big, theta. And then theta divided by T is called angular speed. Okay, in physics, angular speed is denoted by omega, not W. So linear speed equals theta equals radius times the angular speed. Okay? Yeah. So right here, this is the key thing you got to remember. Now here is the example. Here is the example. The example will use this formula. Okay? And then let's look at this example. This example says that suppose that the wheel, there is a wheel down here. The wheel is rotating at a rate of 800 revolutions per minute. Find the angular speed and the linear speed. We know the amount of angle divided by the time is the angular speed. Okay. Okay, we know here is what? 800 revolutions per minute. Okay. And now we know that for 1 minute it rotates 800 circles or revolutions. So we know that 1 revolution is 2 pi. Okay, that 800 revolution. So then we have 800 times 2 pi. Okay, so what we get is 1,600 pi radians per minute. Okay, that will be the angular speed down here, because theta divided by t is omega. So omega equals that. Yeah, the amount of angle divided by the corresponding time. Okay. Now we want to find out linear speed. You know, if we know the angular speed, the linear speed is simply multiplied by radius, we'll get the linear speed. Do we know the radians? We know the diameter. That's 24 inches. So divided by 2 will be the radians. Okay, so the radians times the angular speed. This is each minute it travels this many radians. This is very big radians. Okay, so 24 divided by 2 is 12. So the radians is 12 times 1600 pi radians. So what you get is this. Okay, that's 19,200 times pi inches per minute. This number is pretty big. Normally we like is how much 1 hour for how many miles. Okay, so let's do the following operation. You probably remember 1 foot is 12 inches. Now we have this many inches down here. We want to see this many inches contains how many 12 inches. Okay, then you will convert this number to foot. Yeah, to foot right here. Now this is in feet now. This is in feet now. And we know 1 mile equals 5,280 feet. Since this is feet, you want to see how many 5,280 feet inside. Okay, so you want to divide this number by this number. You will get miles. Okay? Okay, so this one will be in miles now. Then you know minute. 1 minute is how many hours? That's what? That's 1/60th hours. So you multiply this one times that. But remember, 1 divided by 160 is just 60. Okay? Yeah, 1 divided by 1/60th is just 60. So basically, you use 60 here. This number is 60 times this 19,200 divided by 12, and then divided by 5,280. You'll get 57 miles per hour. That's the speed for the linear speed. The object travels, on the circle with this speed. Okay, this one is useful in physics. Okay, I'll see you next time.